Okay guys, so for second semester, we're going to really focus on using statistics to estimate parameters of populations. So that's one of the primary jobs of a statistician, to estimate the characteristics of a population based on a sample. So like what proportion of students drive to school, what their average weight of a teenager is. So to make these estimates, we obviously select a sample from a population, study the members of the sample. We focused on that first semester. However, because of sampling variability, it's important that these estimates are constructed in such a way that also conveys information about the anticipated precision of the estimate. So there's two estimates that we usually make: point estimates and interval estimates. The rest of Chapter 9 will focus on intervals. Today we're just going to look at point estimates. So a point estimate is a single number that represents a plausible value for the population parameter. It's called a point since it's represented by a single point. So you can say like 61% of young Americans favor Social Security reform. So it's a single point. An interval, should be an interval estimate is a range of plausible values for that parameter. It's called an interval since it's represented with an interval on the number line. For example, we could say, based on a recent survey, we estimate that between 58% and 64% of young adults favor Social Security reform. Some places you'll see it written as 61% plus or minus 3%. Usually this is like their margin of error. So using an interval estimate greatly increases the probability we're right. Like for example, if I predict the high temperature tomorrow will be between 0 and 150 degrees, that's usually correct, right? But obviously there's a trade-off between confidence and usefulness. This interval won't help me pick my clothing tomorrow morning. So making point estimates, what should we use? So there are two things to look at when you're choosing a statistic to estimate a parameter. It should have no bias and low variability. So an unbiased statistic is a statistic with a mean value equal to that of the population characteristic that's being estimated. So it's the sampling distribution is centered at the right place. So here are some unbiased statistics. We use X bar is an unbiased statistic for estimating mu. Remember, that's the population mean. So we use X bar to estimate U. We can always use, like we did in Chapter 8, P hat is an unbiased statistic for estimating a population proportion, which remember is P. Now in your book, again, they'll use P and mu, or P and pi, but we use P hat and P. Now, we can also estimate mu using a sample median if we feel like it's a skewed distribution, or we can sometimes use a trimmed mean. So these are used to estimate mu. Obviously, X bar is the best one, but we can use the sample median or the trimmed mean. Remember, that's where we take off some stuff from the top and the bottom to estimate the mean. They are unbiased since their sampling distributions were centered in the right place. So in other words, these estimates weren't consistently too low or too high. So here are some biased statistics. A biased statistic would be like a sample range to estimate the population range. Right? Because this is biased because the sample range tends to underestimate the population range since it doesn't always capture the min or max. Right? Your sample range could be much smaller than your population range. So we really wouldn't use range at all. We would like to use like IQR or something like that. So given the choice between several unbiased statistics, we should always try and use the one with the smallest standard deviation. Or think about the lowest variability. Okay. So make sure you can think about that. So commonly used statistics, kind of what I wrote before. X bar is an unbiased statistic for mu. This is like from chapter 8. P hat is used to estimate P. Variance, we end up, since variance squared, we might think that you may just be able to put in X bar for mu, but that's not really how it works. So this is kind of what we use. We use the sample standard deviation. So you'll see once we get going that like you want to use S squared instead of sigma squared. And the reason that we divide by n minus 1 instead of n is it's better to overestimate variability than underestimate. So for standard deviation and variability, it's kind of a little tricky. Most of the time I'm going to be asking you about either the mean or the proportion. So, but we do use S squared to estimate sigma squared if we need to. So those are the ones that you really need to remember is the mean and the p hat. So X bar and p hat is what we're going to focus on. Okay, that's it.